Hey guys, today we're going to start our second day of transformations of a linear function. So yesterday we talked about reflections, we talked about vertical translations, we talked about stretches, vertical stretches, and vertical compressions, because yesterday we were speaking more about the y-axis. So today you're going to hear more the word with horizontal translations. So if you look right here, we have the word horizontal. Whoops, it's not working. There we go, horizontal translation. So what happens? Now, if you notice here, the change is inside the parentheses. The change is with the x. So what does that look like? It is, instead of saying y plus 3, I'm going to say x plus 3. And so again, let's just go ahead and apply the transformation to what's going on here. So I end up with a 1, a 2, a 3, a 4, and a 5. And then I'm going to go ahead and I'm going to graph these points. I have a -2, 1. I have a -1, 2. I have a 0, 3. I have a 1, 4. And I have a 2, 5. So if you look at this line, it looks as if it's rising up, but we call this a horizontal translation. Horizontal, because horizontal, when you think about the x-axis, is the back and forth. A horizontal translation, this is something that is affecting the x, but you probably see it as going in upward like this. But now I can't turn my computer or my screen around for you. I wish I could. This is one of the rare times I wish I could turn it around, because I can't. But if I turned this around, you would see this vertical axis as a horizontal axis, and it's going to the left 3 times. The left 3 units. In fact, you can see it right here also, 1, 2, 3, that's going to the left 3 units. Now, when I add 3 to the horizontal axis, I would think that it's going to go to the right, but everything that we do when it involves the x is always the opposite, or it will appear to become, or it will appear as the opposite. So I'm just going to go ahead and put a little note for you, so when you start getting confused, you can refer back to this. Opposite of everything you think. So if you think it's going to go to the right, it's probably going to go to the left. If you think it's going to go to the left, it's probably going to go to the right. So we'll just test each one of those out. So I'm going to go ahead and try to be all cool and all that and use a different color. All right, now I have an x minus 3. So now I'm going to go ahead and subtract 3 from it. So I have a -5, a -4, a -3, a -2, and a -1. So again, let's see what this looks like on the grid compared to our parent function, because we always compare everything to the parent function to understand the transformation. So I have a -2, -5, so -2, 1, 2, 1, 2, 3, 4, 5. I have a -1, -4. I have a 0, -3. I have a 1, -2. And if you look, it looks as if it's going down, but actually it is a horizontal translation. What do you think? To the right or the left? If you look, you can see 1, 2, 3 to the right. Horizontal translation, right. Though you would expect, if I subtract, for it to go to the left. Again, if I could turn my paper, you could see kind of what I'm talking about. Just take my word for it. It's a COVID video. I can't show you. I'm not that technologically savvy to show you that. All right, horizontal dilations. What is a horizontal dilation. I'm going to go ahead, well, I'll go ahead and keep this color here. So it says, so now again, within the parentheses, instead of putting a 2 outside of the parentheses in front of f of x, it is inside the parentheses. So it's affecting that. So I'm going to go ahead and write 2x right here. And I'm going to multiply everything down by that 2. Now, again, the graph that you see right now, we have the parent function graph. Let's see what happens when we apply this transformation. And then we're going to talk about what is that? What's going on here? So I have a -2, -4, -2, 1, 2, 3, 4. I have a -1, -2, 1, 2. I have a 0, 0. I have a 1, 1, 2. I have a 2, 1, 2, 3, 4. So if you look at what's happening here as compared to the parent function, now remember yesterday we talked about stretches. And when there was a stretch, it became steeper. But because we're talking about horizontal, guess what? Just to make it very confusing, we're going to not call it a stretch. And we're not going to call it vertical either. We're going to flip everything. We're going to call it horizontal. And instead of a stretch, it's considered a compression. A horizontal compression. And instead of by a factor of 2, it is by a factor, we're going to flip it, of 1/2. So again, everything is getting flipped. So what used to look like a compression, what used to look like a stretch is now compression. So again, remember, when it's affecting the x, everything is going to be the opposite. All right, let's look at the next one, and I'm going to try to be fancy here and do a different color. I'm not really great at this, but let's see what happens. So let's see on this one. Now I have a number that is less than 1. What will happen? Less than 1. We have a -1. We have a -1/2. We have 0 as always. We have a +1/2, and we have a 1. So I'm going to go ahead and graph that. -2, -1, 1, 2, 1, -1, 1/2, -1/2, that is, 0, 0. And you can see this is looking pretty flat. 1, 2. This is looking like a compression from yesterday, the vertical compression. But again, since today everything is the opposite, we're going to call this a horizontal stretch by a factor. What do you think that factor is going to be? Remember, everything's the opposite. So instead of a half, we're going to call it by a factor of 2. All right. Did I confuse you? Use your notes. And I'm going to say this is one of the things when I have the students add things to their formula chart. This is always one of the perfect things to add to your formula chart. Good luck. Please ask me if you're having any questions about that as you work through it. If you're a remote learner, please make sure that you check the key and make sure that you're doing it right. And ask me any questions if you have any questions. I'll see you later. Bye-bye.